Who is ready to multiply some polynomials? Alright guys, so you're going to have a blast multiplying some polynomials in this section, and we are going to talk about so many different ways to multiply polynomials, which some of these you have probably seen before. So whoops, sorry guys. Okay. Alright, so the first example that you guys will be doing today, the first example you will be doing today is the following. We will be multiplying 2x squared y to negative 3x squared minus 4xy plus 5y squared, which, when you have a number outside of a parenthesis, the way we solve is through distributing. Okay, so we'll have to remember some properties of multiplying variables with exponents. Remember, we multiply the numbers in the front of the variables together, and if we have the same variables that we're multiplying together, when you multiply with variables, you add their exponents. You add them. Okay? So go ahead and pause the video and watch example 1. Alright, so example 2. We're stepping it up a little bit. So, kind of the same concept, you guys, except this time we have more than one thing to multiply. So on this one, we're going to start with the first term, x squared, multiply it to all three terms. Then start with the 5 and multiply it all three terms. And we are still going to be using those properties of multiplying variables that contain exponents. So go ahead and pause the video and watch example 2. Okay, now this one's a little different. Okay, so this is called expanding the polynomial. Now, the word expand, that means our original expression will get longer. And the way that we're going to expand it, you guys, if you have something to an exponent, like for example, 2 to the third power means 2 times 2 times 2. So when we expand this out, we will be writing this expression a total of 3 times. Okay, so we're going to write this 2x minus 3y times 2x minus 3y times 2x minus 3y. And then through lots and lots and lots of distributing, we will be solving for our simplified expression. So go ahead and pause the video and watch example 3. Alright, as of this point, we're going to be going into some topics that the honors class needs to know. So if you're not in honors, you do not have to keep watching unless you just want to. So we are going to be talking about a different way that will make your life easier when you expand polynomials. Guys, when we start getting to the third exponent and the fourth power and the fifth power, things get really messy when we multiply this out, which if you saw in example 3, things kind of got messy. So Pascal's triangle is something that we use to help us simplify this process down. Okay, we did a nifty activity on this in class to discover Pascal's triangle and how we use it to multiply polynomials together. Okay, so this is in the form a plus b raised to the nth power. Now, if you remember from the activity, if you look over here, these were the coefficients that we used, okay, when we were multiplying. So these are the numbers you guys came up with in the triangle, which remember, the way we get the numbers. Okay, these three numbers are always 1, 1, 1. To get the number in between them, you have to add them. So 1 plus 1 is 2. That's why the middle number was 2. Okay, the next one, on the ends of the triangle, we always start and end with a 1. Okay, and then we add the two numbers side by side and write it below. So like 1 plus 2 is 3. So I write it in between the 1 and 2. 2 plus 1 is 3. So I write 3 in between the 2 and 1. And then we end with the 1. Okay, the next row, we start with the 1 because we always start and end with the 1. I would add the 1 plus the 3 and we'd get a 4. So I write it in between it. Okay, 3 plus 3 is 6, so I'd write a 6 in between my two 3's. 3 plus 1 is 4, so I'd write the 4 in between my 3 and 1. Okay, and then finally, we end with the 1. Alright, so one more example. Okay, so we start with the 1, then 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5, and then we end with the 1. So, do not try to memorize this triangle. The only thing you need to remember is that the first two rows right here have a 1, 1, and a 1. After that, you just have to know you start with a 1, you end with a 1, and to get the numbers in between, you have to add the two numbers that are above it. Okay, so that's where Pascal's triangle comes from. Now, the reason why Pascal's triangle is important is it gives us the coefficients of all the terms in our final answer. Okay, so that is why it is helpful. Now let's talk about some things about Pascal's triangle. So when you get done, your answer will have one more term than your exponent. So your exponent's n, so it will have n plus 1 terms. So what that means, like if we look here, a plus b to the third, okay, when we get our final answer, we have a total of 4 terms. 1, 2, 3, 4. Okay, so whatever your exponent is, one nifty thing is you will end with one more term than what your exponent is. Another thing about Pascal's triangle, the coefficients are the number from the nth row in Pascal's triangle. Okay, so to figure out what your coefficients are, you go to the nth row in your triangle, which you start with row 0. So this is row 0, row 1, row 2, row 3, row 4, and row 5. So like here, if we're looking at a plus b to the third, we'd go to the third row. So row 0, row 1, row 2, and row 3. So the 1, 3, 3, 1 are the coefficients of our final answer. If you see here, there's secretly a 1 in front of the a to the third. There's secretly a 3 in front of the next term. There's secretly a 3 in front of the, or there is a 3, not really secretly. There is a 3 in front of my next term. And finally, there's secretly a 1 in front of my last term. Now, this is very important. This is the tricky part of Pascal's triangle. Okay, you start with the first term in your exponent, and you raise it to the power that you started with. So since this one has a third power, we would raise a to the third first. Okay, and what you're going to do, each time you write a again, you decrease it by one exponent. So we have a to the third, a squared, a to the first, and this one you don't see an a, so it's like a to the 0, because anything to the 0 power is secretly 1. Okay, now with the second term in your parenthesis, we have a b. Okay, and with the second term, you increase the exponents by 1, and you start with 0, and you should end with your original exponent. So the first term, you start with the original exponent and go all the way down till your power is 0. The second term in the parentheses, you start with an exponent of 0, and you increase by 1 all the way till you get to your original exponent. So that's kind of the process we'll use. So like here with b, we start with b to the 0, which is 1. That's why you don't see it. Then we did b to the first, b squared, and b to the third. Guys, so this is a much faster way to solve different polynomials when we're multiplying. That way we don't have to sit there and multiply 3 different parentheses together or 4 different parentheses together. This is a much faster method. Okay, so we're going to be looking at example 5 now, and we're going to solve this. Instead of writing out my parenthesis 5 times, holy hot dog, that's a lot, we are going to use Pascal's triangle to find what the value of x minus 2y to the 5th power is after it is simplified. So this will be a much faster technique, you guys. Alright guys, go ahead and pause the video and watch example 5. Holy hot dog, you guys. Multiplying polynomials has been absolutely wonderful.